So how do you actually know if an AI is telling the truth or if it's just, well, confidently guessing? We've all been there, right? You ask a generative AI a question, and it spits back this incredibly articulate, completely convincing answer that turns out to be entirely made up. We call those hallucinations. But what if the AI didn't just have to guess the next word in a sentence? What if it could actually check its own math before giving you an answer? Welcome to this explainer, where we're going to unpack a fundamental transformation in how artificial intelligence operates.
We are in the middle of an absolute paradigm shift, and it's called code execution in AI. We're moving away from an era where AI is just a fancy text generator and entering a phase where AI becomes an active agent. We're talking about an AI that can write computer code, actually run that code, and then use the mathematical results to answer your questions. This completely rewrites our relationship with the technology. It takes AI from being just a conversational partner and turns it into a highly accountable, verifiable tool. Here is our roadmap for today's explainer. Number 1, from text to action. 2, data, facts, and transparency. 3, the illusion of security. 4, sandboxes and data privacy. And finally, 5, learning in the AI era. Let's dive right in. Starting with section 1, from text to action. Let's look at the mechanics of code execution. To really grasp the mechanical difference between an AI that just talks and one that actually does things, we have to contrast two very different environments. Traditional generative AI operates strictly in what we call language space. Basically, it generates text based on probabilities, guessing what word logically comes next. Now, it sounds highly plausible, but it is super prone to hallucinations the second you ask it to do complex logic. Code execution, on the other hand, shoves the AI into a formal space. Here, instead of guessing, the AI writes actual Python code, runs it, and produces verifiable computational results. It literally shifts the quality control from a purely linguistic space into a rigid mathematical one. Let's look at how this builds in practice. Think of it like a 5-step feedback loop. First, the AI analyzes your prompt and realizes, hey, a calculation is needed here. Second, it generates a mini Python program. Third, it runs that code in an isolated sandbox. Fourth, it gets the raw output or error messages back. And fifth, it translates those raw numbers back into plain English for you. The coolest part? If the code crashes at step 3, the AI can actually read the error message, fix its own code, and try again. It's a built-in internal feedback loop. Moving on to section 2, data, facts, and transparency, and how we bridge that gap. Let's ground this whole concept in reality with its absolute most powerful use case, data analysis. Imagine you're uploading a raw CSV file and you want to know the growth rate. Without code execution, the AI looks at the text, basically squints, and tries to guess the math. Sometimes it nails it, sometimes it doesn't. But with code execution, the AI acts like a tireless data intern. It reads the file, cleans up the messy data, and processes the exact numbers using standard programming libraries. Boom, the AI executes the code in the background using heavy-duty Python libraries like pandas or matplotlib. It automatically calculates the exact percentages and can even generate a verifiable visual chart of the raw data, completely automatically. It takes your plain English request, like "show me the growth," and flawlessly translates it into precise technical operations. And this brilliantly illustrates a core concept of modern science: reproducibility. You see, the real magic here isn't just that you get a pretty chart, it's the visible scratchpad of code. Because the AI literally shows you the Python script it used, you can see exactly how it handled the data. Did it ignore missing values? Did it format the dates right? The result, the code and the assumptions all belong together. This makes the AI's work 100% auditable by a human. Which brings us to section 3, the illusion of security. Let's uncover some hidden traps. Now, you've got to be careful, because just because a computer ran the code doesn't automatically mean the answer is right. We have to be incredibly wary of a trap called fake precision. Think about it. Would you trust a chart just because a computer drew it? Yeah, we often do. A successful execution gives off this objective, authoritative vibe. But remember, a computer is just following instructions. If the AI writes a script using a mathematically flawed method, the code will run perfectly, but the output will be nothing but precise nonsense. So the absolute crucial thing you need to watch out for are silent errors. A regular bug crashes the program. That's actually great because it yells at you that something is broken. A silent error, on the other hand, runs perfectly. Say the AI's code hits an empty cell in your spreadsheet, and the code silently decides to just drop that entire row of data.
No error is thrown, the program finishes, and your statistics are completely skewed. It will confidently hand you a chart that could literally ruin your company's quarterly forecast. The only way you'd ever catch that is by auditing the code itself. This brings us to a fundamental rule to live by. A successful run does not equal a truthful interpretation. Remember that 5-step loop we talked about earlier? Even if steps 1 through 4 are mathematically flawless, step 5 is where the AI takes those raw numbers and interprets them back into language. The AI can pull the exact right number from the code, but still completely misinterpret what that number actually means in the context of your original question. All right, let's look at Section 4, Sandboxes and Data Privacy and Why Security Boundaries Matter. You can't just let an AI write and run code on servers without massive security risks, right? It requires very strict guardrails, so it operates within a highly secure sandbox. This is an isolated environment intentionally designed to limit what the code can actually do. For example, systems like the Gemini API enforce a maximum 30-second runtime limit, so no endless loops. You can't install custom libraries, and crucially, there is absolutely no external network access. The code cannot reach out to the internet to fetch or send data. These aren't just technical hiccups. They are intentional security and privacy boundaries. But because the AI is actively reading and processing your files in this sandbox, practicing data minimization is absolutely critical. You are handing over your raw data to a cloud system. Before you upload that CSV file, you have to anonymize it. Never upload personal IDs, sensitive health information, or confidential business data that you can't afford to expose. The sandbox is secure, sure, but the fundamental rule of data privacy hasn't changed. If the AI doesn't strictly need it to do the math, don't upload it.
Finally, Section 5, Learning in the AI Era and the New Digital Literacy.
This entire paradigm shift completely transforms education and our responsibilities. Historically, we've always focused on grading the final product. Did you get the right number? Did you do the manual calculation perfectly? But when an AI can write the code to get the right number in 3 seconds flat, the final product is no longer a reliable measure of competence. We are being forced to shift to AI-era exams. We have to focus on grading the metacognitive process, evaluating how a student thinks about thinking. Can they explain the assumptions the AI made? Can they review the code for those silent errors we talked about? Can they justify why a specific mathematical method was even chosen in the first place?
Consider the number 5 for a second. The Gemini API, for instance, allows the model up to 5 automatic retries if its generated code fails. It writes, tests, fails, learns from the error message, and rewrites. It's demonstrating active learning through trial and error. It's exactly the kind of iterative experimental mindset that we have to mirror. We have to stop treating AI like some magical oracle that just grants us the final answer, and start treating it as a dynamic tool that we iterate with.
Ultimately, this is what defines the new digital literacy. We are shifting from being passive AI operators, the people who just type a prompt and lazily copy-paste the output, to critical AI auditors. An auditor doesn't just blindly accept a number. An auditor checks the ledger. In this new world, the ledger is the code, the data inputs, and the environmental assumptions. We have to evaluate the AI's executable work just as rigorously, if not more so, than we would a human colleague's work. Which leaves us with this final, absolutely crucial question to reflect on. When AI can seamlessly plan the analysis, write the Python code, execute the script, and draw the perfect chart, what exactly is your role in the process? I'll leave you to chew on that thought. Your job is no longer to be the calculator. Your job is to be the conductor, the critic, and the auditor. Thank you so much for joining me for this explainer, and always keep questioning the code.